Now I'm going to start to talk about the equilibrium of the rigid body in two-dimensional space. Before we can start to talk about how we analyze the equilibrium of the rigid body, we first need to know how to draw the free body diagram of that rigid body. So before doing that, let's see what's the free diagram. If you remember, the free diagram of the any object is that when we want to draw the free body diagram, we will disconnect that object from anything that is connected to that. So assume it's not connected. If there's any support, anything connected to that, we disconnected all from those connections. And then we applied all external forces on that object. External forces are two types. One type that actually are the active, or the one that want to make the object move, like the weight, or if we have putting any external forces on that. The second type of external forces are the forces that they want to keep the object in place, and these are the forces that as a result of having the support, so the support want to keep it in place. So to draw the free body diagram, first of all, what we are doing, again, we remove all the support, all the connection. Then we add all the forces that want to move that object, and then we add all the support reaction that wants to keep it in place. That's how we are going to get the free body diagram. But before that, let's very quickly say what's the rigid body. When we are talking about the rigid body, we are talking about the object that when we apply forces on that object, it does not deform. So there's no deformation in an object when we have it. And this is the very good assumption for most cases, especially, for example, when we're talking about like some material like steel. There are other type of analysis. I don't. In statics, we always consider that the body is rigid and it does not deform. And then later on in the strength of material, we'll start analyzing the object based on deformation. So if it is deformed, so what's going to happen, and how the forces, or most like the internal forces and the deformation will affect. So in the statics, we assume there is no deformation, it's always rigid, and it's not going to deform in any way. So let's go back to the free body diagram. When we want to draw the free body diagram, as I said, we remove all the connection and support, and then we put all the forces on that object, and then we add all the reaction from support to that object, and that's how we draw the free body diagram. The part that at the beginning might be a little bit confusing is the part that we want to replace the reaction of the support. When we remove the support, we have to put something in place. We have to replace it with the reaction forces, so that reaction forces actually mimic the support itself, or they behave exactly the same as the support was there. As a simple example, before I start to do that, let's look at a very, very simple example. Assume I have there's a ground, and there's a ball sitting on that ground. If I look at that, I see how that ground is support that ball. This ground only holds this ball from falling. It doesn't let it go down, but it doesn't restrain it in any other way. So that ball can move in the left or right direction, or it can go up, or it can rotate. So it doesn't restrain it anyway. So if I want to draw, and that ball has a weight of W. If I want to draw that free body diagram, first of all, I draw that ball and disconnect it from any support, so that object. Then I start to add the external forces. First, active forces, the forces that want to make it move, or to move it, and for that case here is the W. And then I have to add the reaction support. This when I remove that ground, I have to add the reaction support, or I have to add the reaction that exactly mimic what that ground was done. So that ground doesn't start the ball moving in the left or right, so in the x direction. So there's no limitation in the x direction, so I don't need to do anything there, but I can move in that direction. That ground doesn't stop it from rotation, so I don't need to restrain its rotation. It can rotate, but it restrains it from going down. So I have to put force there, the reaction force there, to stop that force, that ball going down. So what I'm gonna do is I'm gonna just add R in the y direction to make sure that ball is not going down, so it's always holding it there. So this is the free body diagram of that ball I have here, and this is the active force and this is the reaction force. So that's active force, and want to move that ball, and this is the reactive force which mimic the support I have here and try to stop that ball from moving. This is general idea how we are gonna do that do that for support. Mainly we have 3 or maybe say 4 type of support we used a lot, and I'm gonna show you how we are gonna use them. The very first type of support is called roller, and most of the time is showed as it is showed like that, like this. So assume I have an object connected to that support, and there is a force here, F, and I want to draw the free body diagram of that object. So first of all, I draw the object by itself. So I draw the object, and then I start to add external forces. So I draw the object, then I add the external forces. First, the active forces. The forces want to move it. So this is the active force. It's the external active force. Then I have to add forces to mimic the effect of that support. The roller support is the kind of support that if, for example, you consider this marker, the roller support doesn't let it go up and down. So it's all like that. So if I hold it here like that, it doesn't let that goes up and down, but it doesn't hold it from going back and forth, and it doesn't hold it from rotation. The roller support is it's like the wheel. If you assume the car and there is a wheel, that wheel doesn't stop the car moving back and forth. And if you, for example, bring up one side of the car, it doesn't stop it from the rotation, but it stops it from going down in case of the car. Here the roller is very similar to that. It only doesn't let it go up and down, or in other way, in normal to the direction of that support. It doesn't let it go up and down, but it doesn't provide any support in X. So it lets it go in the Y or left. So for example, if I draw here some roller like that, so it was like that, it just let it move left or right. So let it move left or right. Also, it let it to rotate. It doesn't stop it from rotation. The only direction it doesn't let it move is up or down. So to mimic that, I'm gonna add one forces here and says, okay, I replace that support with R, the Y direction. So it's a support, it's a reaction support, the Y direction. You see, I put it in the positive direction. I don't know which direction it's gonna be, because depend on is, for example, if the force is the opposite and is pulling it up, so that reaction is gonna be in the opposite way. But it doesn't matter. You don't need to worry about that. We say that we add the force in the Y direction that stop it from moving in the Y direction. When you do the analysis, if the magnitude of that comes out negative, it means that that force, that reaction force, is actually downward. So most of the time you put it in the opposite direction and do the calculation. If it comes positive, it means that the direction you choose is right. If it comes negative, the direction you choose is wrong. We just assume. So I add the force to make that point doesn't move up and down, That's external force and the object. So that's how we are doing it with the roller. The second type of object we have is called a pin. It's the second type of support, and most of the time it's supported like with the simple. So remember the other one, the roller usually showed like a triangle with a line beneath that, and this one is just triangle, doesn't have any line beneath that. The pin is, and assume this is the external force. So to draw the Freebody diagram, I draw the object, then I add external forces, and external forces apply on that. So this is the external forces. The pin is the difference between pin and the roller is that the pin doesn't let it move up and down. Also, it doesn't let it move left or right. So if I consider that it does in the roller, it can move left or right, but in the pin it cannot move left or right. It cannot go up and down, but it can rotate. It restrains it from going left or right. It restrains it from going up and down, but it lets it rotate. So when we want to add the support force to the reaction force to mimic that, so we add one to make sure it's not going up or down. And again, we assume it's upward. If it comes downward, we'll find that later. And we add support to keep it in a place that doesn't let it go left or right. So we have one to make sure it doesn't go left or right, one to make sure it's not going up and down, and we just assume the direction. And then when we are doing the calculation, we'll find out if the assumed direction is right or wrong. The third type of support that we have is called fixed. And it's like that. If I have an object, that object is fixed in a place into whatever support we have. This type of object is like that. If I assume I grab that marker like that, so it doesn't go left or right. It doesn't let it go up or down. It doesn't let it to rotate. It doesn't let it to move in any way, if I want to say. So when I want to draw that again, I draw the object itself, disconnected from any part. Then I add external forces that want to move it. And then I start to add the reaction forces that want to keep it in place. So this one doesn't let it goes up and down. So I have to add the reaction force to stop that point going up or down. So I have to add RY, so make sure it's not going up and down. Then it doesn't let it go left or right. So I have to add another reaction to make sure it's not going left or right. Also, it doesn't let it to rotate. So I have to add again the moment to make sure it doesn't let that point rotate. So if it wants to rotate, that moment actually hold it in place and restrain it in place and doesn't let it move. So if it's good, we are gonna have these three. So when we have the roller, it just doesn't let it go up or down. So we have one reaction. When we have a pin, it doesn't go up or down, left and right. So we have two. When we have a fix, it doesn't let it go up and down. It doesn't go let it left or right, and it doesn't let it to rotate. So we are going to have three of them. The other case that sometimes we may have it is if we have a cable, and if we have an object that, for example, if this is a force, and then it's held by, well, let's say a cable here at this point. The cable is like that. So again, we draw the object, we draw the external forces on that object. The cable, the only thing the cable support is tension. It just is a tension. It doesn't let you to move along its direction. It doesn't hold it from X or Y or Y, X. It doesn't hold it from going left or right. It doesn't hold it from going up or down. It doesn't hold it from rotation. The only direction it holds it, it doesn't move. It doesn't let it move along that rope. If I push it, if I pull it from this direction along drop, it doesn't do that. But if I move it in any other direction, it doesn't resist to that motion. So because of that, the only thing that the rope apply is the tension, and it is going to be along that rope. Remember, if I pull it, it's not going to also resist about if I pull that object. So it's only if I mean, if I push it, if I pull it, it does. But if I push it toward that cable, it doesn't do anything. So that tension is the only thing that the rope would support, and it's always along that cable itself. But mostly we are using these three first type of that. So it's a roller, pin, fix, and sometimes we may have a cable. So if you have a cable, we replace it. So if you have a roller, we replace it with single support that doesn't let go up or down. And here the roller is horizontal, so it's up and down. If the roller was vertical, so it doesn't go, let it go left or right. So it depends on, the roller doesn't let it move normal to that roller. So if it's for example here, and if I had it, if I have a roller like that, assume if I assume that I have an object like that and the roller was like this. I have an object like that and the roller was like that, then the Freebody diagram of that was the object, that was the F, because the lower, in this case, it doesn't hold it from going up or down, it just doesn't let it go left or right, so it's going to be R X. So remember that the roller always restrain the motion normal to its position. So if it is sitting in the X direction, so it doesn't let it go up down. If it's sitting in the Y direction, it doesn't let it go left or right. So depend on its orientation. So any orientation it doesn't let the object move in the normal direction to that orientation. So like here, if I have it, for example, sitting like that, if it sits like that, and I have a object connected to that like this, assume I have a coupler, so then it's going to be like the Freebody diagram is like that, external forces, and then the R would be like that. It's a normal to that surface. So remember, when we have the roller, the R is always normal to that roller. So if it's horizontal, the R is vertical. If it's vertical, the R is on. So if it has any other orientation, the R is always normal to that direction. Pin, doesn't matter which way it is, it never lets in either X or Y direction. So it doesn't let it to move in the X or Y direction. The fix, the same, doesn't let it go in the X or Y direction, also doesn't let it to rotate. And the cable also only provide tension, it doesn't provide any other support. So I'm gonna just show a couple of examples here that what we are gonna work with that. So assume I have a beam like that, and I have a, for example, 10 Newton here. So if I want to replace that, draw the Freebody diagram of that, I'm going to draw that beam itself, and then I'm going to draw the external forces, which is gonna, in this case going to be 10 Newton. And then here I have a roller, so I'm going to replace it with normal to that roller. It doesn't let it go up or down. So now let's make it A and B. So it's the A, B. So it's going to be one support, one reaction forces here in the Y direction, and here I have a pin, so I have to add 2, so it doesn't let it to go up or down. So I'm going to have 1 here and doesn't let it go left or right. So I have here. So I have these 3, and that's that. So this is my Freebody diagram, and I will start to analyze that. Similar again, assume I have, for example, beam. It has a fix at one end and the pin in another end, and then I have a 2 Newton here and 5 Newton here. Yeah, 5 Newton here. So draw the Freebody diagram first. I draw the object, or draw the beam. Then I put all the external forces. First the active forces, which is going to be the 2 Newton, and then it's going to be 5 Newton here. So these are external forces, and then I have to replace the reaction of the support. So I have to replace the support with the reaction. Here I have a pin. The pin doesn't let it go left or right or up and down. So I'm gonna, it doesn't let it go up and down. So let's name them. Again, if this is A and this is B, so it doesn't let it go up and down. So it's gonna be Y, and doesn't left or right. So it's a B X. Here the same for this is the fixed one, so it doesn't let it go up and down. So it's gonna be A Y to hold it from moving up or down. Then it doesn't let it go left or right, so we replace it with AX to make sure it's not going left or right, and doesn't let it to rotate. So we are gonna add M. So make sure that it also hold it in place and doesn't let it to rotate. Another example, we can look into that. For example, now let's say this time assume I have a same here. I have a fixed end, and then I have the roller here. So it's gonna be A, B, and then assume I have a, for example, distributed load from here to here. I want to replace that. So again, I'm gonna just draw that part itself, and then I add the active forces on that. So all the active forces I have here is just these distributed load. And then at the A, if I come to A, see, it doesn't let it go up or down, so I have to AY to make sure it's not going up and down. It doesn't let it go left or right, so I have to add the force to make sure it's not going left or right. Also, it doesn't let it rotate, so I'm going to add the moment to make sure it's not rotate. When I come here in the B, I have the roller, and the roller is always doesn't let it to move in a normal direction to that roller. So this is the normal direction, so I'm going to have the B is like sitting there and doesn't let it to go move in that direction. So I add it to make sure that's going to hold it in place. And then later on, I can replace this distributed load with a single load and do my analysis. So in majority of the cases we have it, there are things like we have support like that. So to draw the Freebody diagram, one more time, we just draw the object itself, then add all the active forces and then all the reaction on that. One last point I want to mention is that all the forces we put on the Freebody diagram are external forces. If there is any internal force in the system, we don't put it on that object. All the forces are external forces. So this external forces, and then the reaction of the support. So we put external forces, including these active forces, those external forces, and reaction of the support. We do not care about the forces that are inside that members. We don't care about the internal forces. So the forces we put in, they're the external forces and reaction of the support. So one more time, when you want to draw the Freebody diagram, draw the object disconnected from anything. Just draw the object itself. Put all the external forces that want to move the object, and then put all the reaction from the support that wants to hold the object in place. And when you have that free body diagram, then we can start to do any analysis we want to do on that object. And from there, for example, we can look into the equilibrium or any other analysis that we need to do.